If two triangles are congruent, then I have 6 pairs of corresponding parts that are congruent. If I want to go the other way and look at the converse of this, and I want to prove two triangles congruent, I need to figure out what parts need to be congruent. Well, it turns out that I don't need to prove that all 6 pairs of corresponding parts are congruent. I only need parts. The first way to prove two triangles congruent is by proving that we have 3 pairs of congruent sides. I can actually ignore the angles and prove that the sides are congruent to prove that my triangles are congruent. In order to use the side-side-side congruent postulate, I need to show that AB is congruent to DE, BC is congruent to EF, and AC is congruent to DF. I don't need to show anything about the angles as long as I have 3 pair of congruent sides. That's enough to prove that I have congruent triangles. Let's take a look at the side-side-side postulate in coordinate geometry. If I want to prove that triangle ABC is congruent to triangle DEF, I'm going to use side, side, side. And in order to do that, I need to prove that the measure of AB is equal to the measure of DE, and the measure of BC is congruent to the measure of EF, and the measure of AC is congruent to the measure of DF. Well, in order to find measure in coordinate geometry, I need to use the distance formula. The distance formula is the difference of my x values squared plus the difference of my y values squared added together, and then the square root of that. So I need to find these ordered pairs. A is at -1, -2, -3. B is at 2, -2. C is at -2, -1. D is 1, 0. F is 2, 2. And E is -2, 1. So let's apply the distance formula to find the length of AB. I'm going to take the square root of my x's subtracted and then squared and add it to the difference of my y's subtracted and squared. So if I have AB, I'm going to take 2 minus -1 and -2 minus -3. x2 minus x1, y2 minus y1. And I'm going to do that math. 2 minus -1 is 3. 2 minus -3 is +1. So I end up with the square root of 9 plus 1, which is the square root of 10. So the measure of AB is the square root of 10, which is approximately 3.16 long. Well, I need to show that DE is also this same length. So I'm going to use the distance formula again, but this time with DE. So I'm going to take -2 and subtract 1 and square it, and then 1 minus 0 squared. -3 squared plus 1 squared. Well, negative 3 squared, negative times a negative, is actually a positive 9. So the measure of DE is also the square root of 10, which is approximately 3.16 long. So my first sides check out. I have a pair of congruent sides. Now I need to go to my second pair of congruent sides. I need to find the measure of BC and the measure of EF. Again, I'm going to use the distance formula. BC, negative 2 minus 2 plus negative 1 minus negative 2 squared. Negative 4 squared plus 1 squared. Negative 4 squared is positive 16. 1 squared is 1. So the measure of BC is equal to the square root of 17, which is approximately 4.12. Now I need to make sure that EF is also the same length. So I'm going to use the distance formula with EF. EF. So I'm going to take 2 minus negative 2 and square it. And then I'm going to take 2 minus 1 and square it. 2 minus negative 2 is positive 4 plus 1. 4 squared is 16 plus 1. So the measure of EF is the square root of 17, which is approximately 4.12 big. So I have a second pair of congruent sides. Now I need to finally make sure that my third pair of sides is congruent. I need to make sure that the measure of AC is equal to the measure of DF. So I'm going to take the square root of AC, or find the distance of AC. So I'm going to have negative 2 minus negative 1 squared plus negative 1 minus negative 3 squared. So I have negative 1 squared plus 2 squared, which is going to be 1 plus 4. So the measure of AC is going to equal the square root of 5, which is approximately 4.2. Well, this 3 is actually going to get rounded to 4 because this 6 makes this a 4. So 2.24. Now I need to find the measure of DF. Square root of 2 minus 1 squared plus 2 minus 0 squared. I end up with 1 squared plus 2 squared, which is 1 plus 4. So the measure of DF is the square root of 5, which is approximately 2.24. In order to prove that these two triangles are congruent in coordinate geometry, I'm going to use side, side, side. To find length, to find measure in coordinate geometry, I need to use the distance formula. And I actually used the distance formula 6 times to show that I have 3 pair of congruent sides.